IB, beginning chapter 11, we're going to start with our trig equations, and we are going to start first just by looking at how we would do this graphically, and then we'll also take a glance at how we do this algebraically, but most of the algebraic equation solving we'll save for our next class. But just taking a look at this example, we're asked where 2 sine of x is equal to 1, and we're looking at a window of negative 2 pi to 2 pi. So what we basically are looking at are 2 separate functions, one of them being 2 sine of x, we'll call that function 1, and the other one is when just y equals 1, and that's our function 2. And we're setting them equal to each other. So we're really thinking about when these 2 graphs would intersect each other, when these 2 functions share common points. So when we take a look at our graph, 2 sine of x just changes our amplitude. So instead of sine having a max at 1, we now have 2 sine having a max at 2 and a minimum at negative 2. And we're in the appropriate window from negative 2 pi. So we have 1 full revolution to the left and 1 full revolution to the right. So we have 2 full revolutions between negative 2 pi and 2 pi. Y equals 1 is just a horizontal line at 1. So thinking back to a few of the examples we've seen this year and then also in year 10, when we're reading a graph, we are taking a look at, well, let's say x were 1. So let's just say for a moment that our first function, which is the 2 sine x, at 1, what would we really be looking at? So 2 sine and x value of 1, we're really taking a look right here, and we'd be following the graph up to find this point. So similar, if we were looking at our second function at an x value of 2, so that our second function is 1. Oh, goodness. So 1, because y equals 1 is just a horizontal line, any x value that you choose is going to have a corresponding y value at 1. So if I looked at x at 2, and this is our second function, I'm looking right here. Okay, so just a little revision of how we read these graphs. But now we're looking at where we have an intersection. So we're looking at where these 2 graphs overlap each other and share a common point. We can already tell that there are 4 points of intersection between negative 2 pi and positive 2 pi. 4 points of intersection. So we could of course look at the graph and approximate where we think these intersection points are, but we want to be really, really specific. So the first way, since this is one that we can handle by hand, we're going to go ahead and just algebraically take a look at how the graph matches our work algebraically. So first of all, we want to take a look. If this is 2 sine of x, let's isolate our sine of x, because ultimately we want to isolate x. So sine of x is equal to 1/2. And what that really means for us is that x will equal inverse sine of 1/2. All right, so what angle does sine have a ratio of 1/2? Well, we're talking about our 30-degree reference angle. If we think about our 30, 60, 90 triangle. All right, so 30 degrees, 1, root 3, and 2. So 30 degrees, or we're talking about radians. So I'm going to leave my answer as pi over 6. Now let's think about this for a moment. Pi over 6 is in the first quadrant, and we're counting by 6. So we have 6 pi over 6s that basically take us to pi. And remember, we have 2 values of sine that would satisfy this equation, or 2 angles that would satisfy this equation, because at pi over 6 we have a ratio of 1/2, but that also means that at 180 minus pi over 6, or pi minus pi over 6, which would be 5 pi over 6, we have an equivalent ratio, since we are talking about the same reference angle. All right, so not only do we have pi over 6 that would satisfy this equation, but since we're looking at the window between negative 2 pi and positive 2 pi, we're also going to be including 5 pi over 6. So if I go back up to my graph, right now, pi over 6, right here, that's the first one that we found. So pi over 6, so pi is here at 3.14. If I divide that into 6, this is the first time that we wind up having a solution. 5 pi over 6 would be right before we hit pi and this intersection point right here. So we have 2 right now, would satisfy that equation. So we have pi over 6 and 5 pi over 6, excuse me. So that's in our first and second quadrant. However, our window goes all the way back to negative 2 pi. So that means I'm going to be traveling in a negative direction to find the other 2 values that would also satisfy this equation. So let's just think for a moment around our unit circle. I'll use green for this. If we're starting at 0 and moving, normally we would move in a counterclockwise direction, starting from 0 and working our way counterclockwise around the unit circle. So if I'm moving to negative 2 pi, I'm actually going to travel in a negative direction, which for us would be clockwise. So if I'm moving clockwise, let's think what's going to happen here. In order for me to hit the same value, because if I move clockwise 2 pi units, I'm basically going to make one full circle in the negative direction. So for me to find an equivalent value at these two original reference values, reference angles, I am going to wind up moving all the way around to not only, let's say this is pi over 6, negative 2 pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4, negative 5, negative 6, here's negative 7. So at negative 7 pi over 6, I have an equivalent value for sine of 1/2. I cannot use the reference angles in the third and fourth quadrant because those would give me negative sine. So I want to have a positive value for sine. All right, so negative 7 pi over 6 works. Negative 8, negative 9, negative 10, and here's negative 11 pi over 6. And then I get to negative 2 pi, and that's the end of my window. So I had to travel in a negative direction to find the corresponding values for sine at 1/2, and that wound up being at 7 pi over 6 and negative 11 pi over 6. So therefore, for some of these questions, we are going to have more than just 2 answers, and that just depends on what window we're given. And now I have found my other 2 values for intersection points that wind up satisfying 2 sine x equals 1. Our second example starts to take a look at, we're beginning to take a look at 2 functions again. However, they're a little bit more complicated and not ones that I would maybe want to tackle by hand. So solving graphically with a calculator is going to help us find intersection points, similar to how we did the first question, when we have some questions that are not quite possible at the moment to solve by hand. So for this one, we're going to set up 2 functions in our calculator. Again, the first one being 2 cosine x minus 3x, minus 3 sine x. So we'll set this up as our first function, and then x plus 2, which is a linear function, as our second function in our calculator. Make sure we set your window correctly. Go ahead and pause here, go and set up your calculator, enter both these functions, and let's see what we get. So if you just enter these 2 functions and keep the regular window, this is the picture that you'll see. We want to go ahead and change our x values, our min and our max, to negative 2 pi and positive 2 pi. Remember, in order to get the correct window settings, we go to Menu, Window, Window Settings, and then you can actually type in negative 2 pi as your x minimum and positive 2 pi as your x maximum. So if we adjust our window accordingly, this is the graph that we wind up getting. It's always important to make sure you have the correct window set on your calculator, because otherwise, so right now we're looking at 3 possible solutions, so 3 x values, but if one of these happened to be outside of the window that we were looking at, then I would not include one of them. So for example, if the window was only from negative pi to positive pi, I might not be including this value down here because that looks like it's going to be beyond negative pi. So just be careful that you're always including the values that you should within the window of the question that's set for you. So let's go ahead and use our intersection to find the intersection points. So analyze, intersection, and we're going to set our intersection to the left of the first point of intersection, and then as soon as I cross the intersection, as I move my cursor to the right, the calculator says I found an intersection point, and it will find it for you. Let's go ahead and repeat this for the other 2 points. So we have found 3 points of intersection, and the question was asking for to find the x values, and we know that because these two functions are representing the y values. So when we're forcing these two functions to be set equal to each other, we're finding basically when they share x and y values, because the y values are the same. So we're going to go ahead and write down our x values as our answers. So making sure that I write down 3 significant figures, my first answer is going to be negative 4.80. And I do have to include the 0 for 3 significant figures because I am rounding down to 0 with that 4 as the next digit. And then we have negative 2.7683. So we're going to write down 7, 7, and 0 is my last one. All right, so I do actually have 3 x values that satisfy this window when I set these 2 equations equal to each other. All right, guys, so let's just recap what we've been talking about. If we are asked to solve algebraically and we're not using a calculator, we've got to have values that we can actually find using our 2 special triangles. So first step, isolate the trig ratio. So I have my trig function cosine x is equal to the ratio of 1/2. All right. Second step, identify the reference angle and the special triangle. So with an adjacent side of 1 and a hypotenuse of 2, I'm looking at a 30, 60, 90 triangle, and I'm looking at a reference angle of 60, so that I have an adjacent side of 1, and I've got my root 3 there, and I've got the 2 there. So I have a reference angle of 60. All right, so far, 2 steps down. We're going to go ahead and solve the equation to find the 2 values that satisfy this equation between 0 and just 2 pi, and then I'll go ahead and take a look at what would happen for 4 pi. All right, so cosine, to have a positive value of 1/2, I'm going to use pi/3 in the first quadrant and 5 pi/3 in the fourth quadrant, where cosine is positive. And I'm writing my 60-degree reference angle as radians because the question is asked of me in radians. All right, so if we think about our first pi/3 is at 60 degrees right here. There's pi/3. And then I've got to go around, so pi/3, 2 pi/3, 3 pi/3, which is pi, 4 pi/3, 5 pi/3. All right, this is if I just go around one full time, 2 pi units. I need to continue to go all the way to 4 pi units. I'm going to choose green here. So that means this is 6 pi/3, so 7 pi/3 would be my second time around, and then 8, 9, 10, 11 pi/3 would be the second time around when I hit 5 pi/3 before I complete my second full circle at 4 pi units. So basically what I just did was I just added on a full 2 pi to both of my original values. All right, because remember 2 pi would be 6 pi/3. So I end up with 7 pi/3, and then I add on and I get 11 pi/3. So I actually wind up with 4 answers because my window now goes out to 4 pi instead of just 2 pi. So we have pi/3, we have 5 pi/3, we have, let's see, 7 pi/3, and 11. All right, so more of these to come, but go ahead and make sure that you've got your 4 steps down so that we can correctly and efficiently work through these trig equations. Have a good night.